Okay, our next topic is friction. It's chapter 20. And friction acts on rough surfaces. So whenever we see a rough surface, we have to consider friction. And friction acts in the opposite direction to motion. So looking at this object in the textbook example, this force is pulling this object to the right. But because this object or this body is just about to move, so the textbook says in the example that this object is just about to move, well then that 32 newtons to the right is equal to the frictional force acting in the opposite direction. So whenever we see that the bodies are just about to move, then the force to the right is equal to the frictional force to the left. And that happens whenever we see that an object is about to start to move. So because we know that, we can resolve horizontally. The horizontal forces to the right, 32 newtons, but because it's just about to move, the frictional force acting in the opposite direction is equal to 32 newtons. You can also resolve vertically as well. The normal reaction is equal to our 60 newtons. The next type of question is whenever it's on an inclined plane. Once again, this is about bodies that are just about to move. So objects are just about to move. Now a block of mass 4 kilograms rests on a rough plane inclined at 25 degrees to the horizontal. So it's a rough plane, so we have to consider friction. Key bit of information here is that it is just about to move. Now if it is just about to move and it's resting on the plane, then it is just about to go down the plane. It's going to fall down the plane. That's going to be the direction of motion. Now if that is the direction of motion, then friction is acting in the opposite direction. Friction is acting up the plane. So because friction is acting up the plane, there's going to be a force acting down the plane. We're going to resolve our forces. So here is our friction acting against the direction of motion. Here is our 4g sine 25 acting down the plane. And because it is just about to move, those two things are equal. Therefore, the frictional force acting up the plane is equal to the 4g sine 25 acting down the plane. Also, the reactional force, the normal reaction, is equal to our 4g cos 25 into the plane. So similarly, this is about objects that are on a plane, but there is an extra force applied. So reading this textbook example again, a block of mass 5 kilograms rests on a rough plane inclined at 30 degrees to the horizontal. This question actually gives us the frictional force. So the frictional force on the block is 12.99 newtons, but the direction of this frictional force depends on the scenario. So in this question there are two scenarios, A and B. So find the least force needed to move the object up the plane. So if we just concentrate on part A, if we're going to imagine that the block is going to be moving up the plane, then friction is going to act in the opposite direction and move down the plane. So here's our diagram for part A. F here stands for friction. The reason why it's acting down the plane is because we want to find the least force, which we'll call P, required to move it up the plane. So the direction of motion is up the plane. Friction acts the opposite way. Now because it is just about to move, well then we can say this, that the force acting up the plane is equal to the forces acting down the plane. So P is equal to our frictional force plus our 50 sine 30. And we have already been told our frictional force, so we add our 50 sine 30, which we got from resolving our 50 newtons. Part B of these questions, or C of these questions, you might be asked for the normal reaction as well. That's just whenever we resolve perpendicular to the plane. The second scenario, part B, find the least force needed to stop it from falling down the plane. So if it's falling down the plane, then the motion of the object is down the plane. So for part B, the motion is down the plane, therefore the friction is going to be acting in the opposite direction, which is up the plane. So here's our diagram for the second part. So we are finding the least force needed to stop it from falling down the plane. Once again, I'll say it again, the motion is down the plane, therefore the friction is acting against it. So friction is acting up the plane. And we need to apply an extra force up the plane to make sure that this 50 sine 30 and the forces acting up the plane are equal. Why do we want them to be equal? Because it is just about to move. So the friction is still 12.99 from the question, but this time we're adding a force in the same direction up the plane. The 50 sine 30 is resolved from the 50 newtons down the plane, sine always down the plane. So we let them be equal, therefore we can rearrange and find the force needed so that we have the least force needed to stop it from falling down the plane. So depending on the question, A and B, two different scenarios depending on the motion. So whatever direction the motion is, the friction is going in the opposite direction. So just a quick summary. For exercise 20B, you could be asked to find the least force required to either move up the plane or stop it moving down the plane, or both. So if we concentrate on this one, if we want the least force required to move it up the plane, that means that the direction is up the plane, friction acts down the plane. For the one on the right, to stop it from falling down the plane, well then the direction is going to be down the plane, therefore friction acts up the plane, as well as our extra force, P. You'll resolve along the inclined plane for both examples and you will find the force needed.